Networks. Now, there are different types of networks. There's a personal area network, or PAN, which is usually created by a Bluetooth connection between the computer and your associated peripherals. Maybe your printer, headset, keyboard, mouse. That's a PAN. Then there's a local area network. This is isolated to a single geographic area, a building, a house. That's your local area network. Everyone on that land can communicate with each other. Then as we expand out, we move to things like a campus area network. Usually one organization, one business, picture a large conglomerate, large corporation, multiple buildings all together, and they're wired between all their buildings and everyone connects to each other. That's a CAN, or campus area network. I know it's not on your slide, but it's a fair one to include, and it may appear on the exam. As we go a little bit wider, we move to a metropolitan area network. This is a city-wide network. And we're seeing more and more of these appear as more cities add in Wi-Fi or free Wi-Fi. And then everyone is on that city's network that connects. Now, one of the key differences between a metropolitan area network and a CAN is that a CAN belongs to a single organization, whereas that MAN, or metropolitan area network, you've got diverse interests all connected to it, not just one organization, but it is to the whole city. So lots of different organizations, lots of different individuals all connect in it. So a diverse set of users. And then we go the one step above that. A wide area network connects different geographic areas together. In fact, it connects multiple LANs or MANs or CANs together across a much wider area, such as the whole world. In fact, the example usually given for a wide area network is the internet. It's probably the greatest wide area network as it incorporates effectively the whole world. Yes, incorporates Antarctica. It's on the internet, incorporates Christmas Island. The reservation there has internet. It has Christmas Island, Easter Island. They're all there on it, as well as where you are. Okay? It's everywhere. Okay? The whole world can connect on the internet. Now, that's an extreme case. Sometimes an organization will have its own internet, where it's got sites in different parts of the world and they connect together directly to each other. That would still be an internet. Or, I'm sorry, that would still be a wide area network. The internet being the more public one. Now, there are ways in which networks are designed. We're looking mostly at those LANs here. Now, a star topology is going to have a central hub or switch or multi-station access unit called an MAU or MSAU, depending upon when you came into the field. Most books are now just calling it an MAU, and that's the multi-station access unit used with token ring networks, whereas a hub or switch is used with Ethernet networks. But they create a star topology. Everyone connects into that central device. And if you take a look at the picture, you've got that hub in the center, and you've got your server and workstations coming off from it. If you take a look at it, it's kind of like a starburst, hence the name star topology. Now, if a single machine should break, a single line should break, let's say that server goes down, all the other hosts can still communicate with each other. They're still there. I know picking the server is probably the worst example, but it's the only one that looks significantly different, so it stands out. I suppose I should have picked the one that looks like a notebook. Said that one disconnects or has a broken cable. Everyone else is still connected and can communicate. So a single break doesn't affect the other nodes. However, that hub, switch, or MAU should break, everyone is affected. So that is its single point of failure, is the central device. A bus topology. Now this is old Ethernet. Ethernet was designed as a bus, a single line. Continuous line is formed, nodes connected to the next in line, usually done with coaxial cable with T connectors. So you have two coax cables connected with a T connector, and a computer comes off of the T, comes off the bottom end of the T. And the line uses terminators, which are B and C connectors that are 50 ohm or 75 ohm resistors. Terminator absorbs the data signal. If it didn't absorb the signal, it would reach the end of the cable and bounce back. Well, if someone else is transmitting, here comes someone's transmitting, here comes the data bouncing back. Well, it's literally what it looks like, a collision. and all the data is damaged. They would then both have to wait a random amount of time, start listening for an empty gap, and then transmit again. Collisions are a bad thing. By absorbing the signal at the end of the wire, you get rid of that occurring, or at least vastly reduce it. Now, information passes through every single node at least once. Remember, it's going to go all the way to the terminators. Even if the computer says that's for me, it's still going along the cable. Everyone else still sees it. Now, they're only going to pull it up into the computer if it matches their MAC address. We're going to talk about MAC addresses in a little bit. So the node determines that the data is addressed to it based on MAC address, and it reads it. Still continues along the wire, though. It's a simple, relatively inexpensive design. I don't want to call it inexpensive any longer. The price of coax is so much more expensive than twisted pair cable that using a bus topology may now be more expensive than having a switch with twisted pair cabling. Also, there's many other advantages that switch with twisted pair that you don't get with coax. But it is a simple design, machine to machine to machine. But a single break anywhere in that cable will stop all communication. You may be thinking, well, okay, let's say we got that server there. We got one computer to the left. We got 3 computers to the right. Let's say it just breaks to the left of the server. Isn't it just going to cut off that one machine? No, it's going to cut off everyone. Let's say the server transmits. It's going to go both ways when it hits the wire. It's going to hit the break. When it hits the break, it's going to bounce. It's going to reflect. That means all other data being transmitted is going to be corrupted. So a single break effectively stops everyone.